Okay, now this lecture is lecture number 25, Physics 112, and I'm going to go through example 21.3. All right, so this one is a series and parallel resistors mixed, right? So it's a mixture. So if you look at the circuit, the voltage V, this is a longer line, so that's a positive node, and this is a negative node. And there's a voltage source given with voltage V. Then there's a resistor R1 by itself, and R2 and R3 are in parallel. Then you have come back to the negative node. So obviously if the circuit is complete, closed, then you will have the current I going through this resistor R1, and then it'll split into I2 and I3. I call it I2 because that's the current going through the branch with resistor R2. And this is I3 going through resistor with resistance R3. Then these two, I2 and I3, will recombine and it'll become I again once it gets to this branch. Okay? Now, the values for R1, R2, and R3 are R1 is 1 ohms, R2 is 6 ohms, and R3 is 13 ohms. All right? And the voltage V is equal to 12 volts. So what we want to find is, we want to find A, the total resistance. All right? So let me see what do you mean by total resistance. So here I have one resistor R1, and there are two of them in series. Two of them in parallel. So the best thing to do this is to do it step by step. The first one, I'm going to combine these two parallel resistors as one equivalent resistor. So what I'm going to do is, this is still my V. This is my R1, the same R1. Now I put these two together as one resistor, and I'll give it a name. I call it R12. Since they are in parallel, I call it R12 in parallel. Just put a little name, superscript, so that you will remember this parallel. This is still V, this is R1. After I've done that, after I found this, then you see that this and this resistor R1 and this R12 parallel, these two are in series. So now I can put these two together in another combined equivalent resistance. That will be this. And that will be the last one, because that's the only one left. So that is actually R1 and R23 parallel combined, or I can call it R total if I want. All right. So I have to go from this circuit to this circuit, and then from here to here. All right. So let me first find R12B. Right. How do I do that? Well, since these R1 and R2 are in parallel, then I have to use the formula for that. 1 by R12 parallel is 1 by R23 parallel. I don't know why I said R12. This should be R23. Sorry for the confusion. So R23 parallel is equal to R2 plus 1 by R3. So you put in the number. R2 is 6 ohms and R3 is 13 ohms. And so you can easily do the math, and that will give you R23 parallel will be 4.11 ohms. All right. So doing this type of thing, actually, this is done before. Let me write it this way. So this is common denominator. You cannot divide into 13 because it's a prime number. So I just multiply it out. 6 times 13 is 6 times 10 is 60, and 6 times 3 is 18. So that's 78. So 6 goes into 78 13 times, plus 13 goes into 78 6 times. So it is 19 by 78. So that's 1 by ohms, don't forget. And so RP, or R23 parallel, is just 78 divided by 19 ohms, which is equal to, let me do it for you, 78 divided by 13 is equal to, 19. What did I do? 78 divided by 19 is equal to 4.105. So I'll just take 4.105. So the book takes at 4.11 ohms. All right, so it's the same thing. Actually, this is just from the book. Here, I just show you how to do that. Now, to find this R total, of course, then I see that R1 and this R23 are in series. So series is easier for resistors. R total is equal to R1 plus R23 parallel, which is equal to R1 is 1 ohm plus R23P, or R23 parallel is 4.11 ohms. So it is 5.11 ohms. That's the R total. All right. So that's done for part A. Now let's do for B. So this same example 21.3 continued. And for part B, I need to find the voltage drop through the resistor 1. That means I want to find the voltage drop in here. So that means V is equal to IR, so that's I1, R1, or I1 is just I. So this is just V is equal to IR1. So all I need is V1, the voltage drop in resistor R1 is V is equal to I R1. Right? Okay? V is equal to I R1. So now what do I need? I need to find I. Right? I need to find I. I is the current that goes through the whole circuit. Right? So this is the current I going through here, splits here, come back and then become I again. So that's the I that I need. So I need to use this to find I, right? Because this is the same I here. So I'm going to do that current going through this circuit, right? So V is equal to IR from, so V is equal to IR total. And then from there I can find I is equal to V by R total. V is equal to 12 and volts, and R total is 5.11 ohms. We just found that. So I get I, and I is equal to 2.35 amperes. Okay, so this divided by this is 2.35 amperes. I get I. So now from here, then I can find V1. So V1 is equal to 2.35 amperes times 1 ohms, which is R1. So the answer is 2.35 volts. That's a voltage drop across the resistor R1, or in the book they call it IR drop. All right, doesn't matter what it calls, it's the voltage difference, potential difference between the 2 points across the resistor. All right, now for part C, what do we want? For part C, let me go back. So for C, I want the current in I2. So current going through here, right? Current going through here. So we know that V is equal to IR. So the voltage there, right? The voltage there is VAB is equal to I2 R2. Actually, it's also equal to I3 R3, but this part is right now of no interest because the book wants us to find what is I2, right? So we need to know VAB, right? Let me show you the figure again. VAB is from here to here, right? Let's call it A, let's call it B. So at first you have potential V, then going across R1, I lost some energy. So that is what we call the voltage drop, or IR drop, from going from here to here. And we have found that already, IR drop. So if I subtract this IR drop through R1 from V, then I'll get the voltage or potential difference between point A and B, or VAB. That's what we need, right? Because VAB is V is equal to IR, so VAB is equal to I2 R2, then I can find I2. So the point is I need to find VAB first. So in order to find VAB, then I need to find V minus V1, that is your VAB. And V is 12 volt, because we have found that's from the problem given. And V1, we just found that V1 is 2.35 volt. So the answer is 9.65. Just subtract 12 minus 2.35 volt. All right, so that's VAB. Now I can substitute in here. So I2 is equal to VAB divided by R2, which is equal to 9.65 volt divided by R2 is 6 ohms. And the answer is 1.61 amperes. Okay, so I get 1.61 amperes. So for part D, I want to find power dissipation in resistor R2. So P2 is simple. P2 is equal to I2 V2. I can do that. And I2 is 1.61 ampere. And V2 is just VAB, which is equal to 9.65 volt. So the answer is 15.5 watts. All right. And now just be careful. Here I said V2. So that V2 is from going across this wire, and it is the same as VAB. So V2, that is the voltage drop across this resistor R2, is the same as voltage drop from A to B. Okay? All right.